Group 18 elements, noble gases. Which one has the highest boiling point? The highest boiling point depends on molecular size or mass. So, largest one among the given noble gases is xenon. So, xenon has the highest boiling point. Which of the following has maximum number of lone pairs on xenon? All these are xenon compounds. We know xenon noble gas element, there are 8 valence electrons. And we also know that xenon form double bond with the oxygen atom. So here 3 oxygen atoms, so xenon form double bond with 3 oxygen atom. So out of 8 valence electron, xenon uses how many electrons for bonding with oxygen? For each oxygen, xenon uses 2 electrons. So 2 plus 2 plus 2, that is 6 electrons are used in bonding. Remaining how many electrons? 2 non-bonding electrons. That means here xenon contains 1 lone pair electron. Xenon tetrafluoride, here xenon uses 4 electrons for bonding. So out of 8, 4 is used in bonding, remaining 4 non-bonding electrons, that means 2 lone pairs. Xenon hexafluoride, xenon uses 6 electrons for bonding, so 8 minus 6 equal to 2 non-bonding electrons, that means 1 lone pair. Xenon difluoride, xenon uses 2 electrons for 2 of the valence electron used for bonding, so remaining 8 minus 2 equal to 6 non-bonding electrons, that means 3 lone pair electrons are present on xenon. So the one containing maximum number of lone pair electron is in xenon difluoride, that is 3 lone pair electron. The shape of sulfur tetrafluoride and xenon difluoride respectively. The shape can be predicted using VSEPR theory. Sulfur group 16 element, 6 valence electrons on sulfur is 6. Out of 6, sulfur uses 4 electrons for bonding with the 4 fluorine atom, that is there are 4 bond pair electron and it contains 1 lone pair electron. Total electron pair is 5. If all the 5 electron pairs were bond pairs, the expected geometry would be trigonal bipyramidal. Here out of 5 electron pairs, 1 is lone pair. The lone pair will occupy this equatorial position. The lone pair will occupy the equatorial position. The other 2 position, that is the remaining 2 equatorial position will be occupied by fluorine. Sulfur at the center of the triangular plane, and the 2 equatorial position and the 2 axial positions are occupied by fluorine atom. This is the shape. So the shape is distorted to trigonal bipyramidal geometry is distorted to seesaw geometry for sulfur tetrafluoride. Xenon difluoride, we know xenon noble gas element 8 valence electron. It forms 2 bonds with the 2 fluorine atom using 2 valence electron. That means the number of bond pair is equal to 2. Remaining 6 electrons remaining as non-bonding electrons on xenon, so which are present as 3 lone pairs. Total electron pair is 5. So the expected geometry here also trigonal bipyramidal, but here we have xenon at the center of the triangular plane, but this triangular plane positions will be occupied by the 3 lone pairs and the fluorine atoms above and below. So the geometry, these are lone pairs. Lone pair electron. So geometry distorted to linear. So seesaw and linear geometry. XeF2 is linear, SF4 is seesaw. The geometry and hybridization for xenon tetrafluoride. Xenon tetrafluoride, there are 4 bond pair electrons remaining on xenon after using 4 electrons for bonding, remaining 4 non-bonding electron, that means lone pair 2. If the total electron pairs were 6 electron pair, if all the 6 electron pairs were bond pairs, the geometry would have been square bipyramidal, that is octahedral geometry. But here 2 of the electron pairs are lone pairs. They would occupy the axial position. So these 2 are lone pair electrons. So the geometry is distorted to square pyramidal. Geometry is square planar, not pyramidal, square planar geometry, and the hybridization is sp3d2. Match the columns. Xenon hexafluoride. Xenon hexafluoride has got 6 bond pairs and 1 lone pair. Total 7 electron pair. So the geometry is distorted octahedral geometry. XeO3 has 3 bond pairs and 1 lone pair. So total 4 electron pairs. So the geometry is pyramidal geometry. Xenon oxyfluoride, it contains 1 lone pair and 5 bond pair, and the geometry is square pyramidal. Xenon tetrafluoride is square planar. Xenon F6 on partial hydrolysis produces 2 compounds X and Y, and the oxidation state of xenon are respectively in these compounds. Xenon F6 on partial hydrolysis produce 2 compounds. They are xenon OF4 and xenon O2F2. In both the compounds, the oxidation state of xenon is +6. That is, option B is the correct answer. Here fluorine -1, oxygen -2. So the xenon atom carry +6 oxidation state in the first compound. Second compound, fluorine -1, oxygen -2. Total negative charge on fluorine and oxygen is 4 negative, 2 negative, 6 negative. So xenon carry +6 oxidation state. The compound with 2 lone pair electrons on central atom. So this is bromine F5 halogen. Bromine is the halogen, 7 valence electron. Out of 7 it uses 5 electrons for bonding. So remaining 2 electron, that means 1 lone pair electron. ClF3, chlorine again halogen, 7 valence electron. Out of 7, 3 used in bonding, remaining 4 non-bonding electron, that means 2 lone pair. Xenon tetrafluoride, xenon contains 8 valence electron, 4 electrons are used in bonding, remaining 4 electron, that means 2 lone pair. Sulfur tetrafluoride, sulfur group 16 element, 6 valence electron, uses 4 of the valence electrons for bonding, remaining 2 electron, that means 1 lone pair. So the compounds with the 2 lone pair electrons are ClF3 and xenon tetrafluoride, 2 lone pairs. Species isoelectronic with OF2. Isoelectronic means same number of electrons. So how many electrons are present in OF2 we need to find out. Oxygen contain 8 electron, atomic number, plus F2, fluorine. One fluorine atom contain 9 electron, 9 plus 9, 18, which is equal to 26 electron. So you have to find out the species which contain 26 electron. ClO minus, chlorine, we know that chlorine there are 17 electron, atomic number 17, oxygen 8, then 1 negative charge, so 1 extra electron. So how many electron? 17 plus 8, 25 plus 1, 26. 26 electron, isoelectronic. ClF, chlorine we know that 17, fluorine we know that 9, 17 plus 9, again 26 electron. NH2Cl, nitrogen 7 electron, hydrogen 1 electron, 2 hydrogen, so 2 electron, chlorine 17, 17 plus 7, 24 plus 2, again 26, again isoelectronic. ClO2, chlorine 17 electron, oxygen 8 plus 8, 16, so 10 plus 10, 20, 27, so this is not isoelectronic. So the answers are ClO minus, ClF and NH2Cl. These 3 are isoelectronic with OF2. Same number of electrons, 26 electrons. Which of the following is isoelectronic pair? This one again you have to check with each pair. Iodine atomic number is 53. That means 53 electrons are present in iodine. Chlorine contain 17 plus 17, 34. 50 plus 30. ClO2, it is not isoelectron ClO2 because chlorine we know only 17 electron, oxygen 8 plus 8 only 16. So these two are not isoelectronic, very clear. ClO2 BRF, chlorine 17 electron, oxygen 8 plus 8 16 electron. Here bromine we know bromine atomic number 35, that means 35 electron plus 9. These two are again not isoelectronic, not possible. BrO2, BrF2. See here bromine is common, then we can compare the remaining O2 minus F2 plus. O2 minus contain how many electron? Oxygen 8 plus 8 16, 16 plus 1 17 electron, plus bromine contain 35 electron, 35 plus 17. Here bromine 35 plus fluorine contain 9 plus 9 18, 18 minus 1 17 because it carry one positive charge, so these two are isoelectronic, same number of electron. Cn minus carbon we know 6 electron, nitrogen 7 electron plus 1 electron due to the negative charge, oxygen 8 electron, 8 into 3 that is 24 electron. So these two are also not isoelectronic. So the answer